Hi students, welcome back. Angle between the two lines is going to be the part for this session what we are going to have. In this session, we'll see the slope concept that we have just done into the previous part to go into the details of angle between two intersecting lines. So let's start with this. So let's move on to angle between two lines. So for this concept, we have to consider first of all two lines, and that will be given by this. So this is a figure in which you can see the rectangular axes and the lines. This is the line L1 and this is the line L2. So we have to find out the angle between two lines and a mathematical formula that what will be the relation between the slope and the angles. So this is the required angle, which is the pi minus theta, and if this theta is the angle. So see, this line L2 is making an angle theta 2 with the positive side of the x-axis. This line L2 is making an angle theta 1. So I can say that theta 2 will be equal to theta plus theta 1, because theta 2 is the exterior angle to the triangle which is made by these two lines and the rectangular axis, and theta plus theta 1 are the opposite angles which will be equal to the sum, and that will be equal to the theta 2. So next in the series will be theta, that is theta 2 minus theta 1. As you know that whenever two lines intersect, there are two pair of angles that is being formed. The first angle being this one, this is the first angle, and the other one will be the supplementary part of that, and this is the second angle. So theta being the angle that is in between the lines, and pi minus theta is, yes, obviously the other angle. So what we can say, if we take the tan on both the sides, this is tan theta, and this will be nothing but tan of theta 2 minus theta 1. So from the knowledge of trigonometry that we have acquired, we can expand this in terms of theta 2 and theta 1, and mind you, we know the values of theta 2, tan theta 2 and tan theta 1. Why? Because tan theta 1 is nothing but the slope of the line 2, and tan theta 2 is nothing but the slope of the line L1. So let's move next into the series. So tan theta can be written as tan of theta 2 minus tan of theta 1 upon 1 plus tan theta 2 into tan theta 1. As explained over here, tan theta 1 is in slope of the line L2 and tan theta 2 is the slope of the line L1. And as explained earlier, the second angle will be tan pi minus theta, that is minus of tan theta, that will be nothing but a minus sign before this complete expression. So tan theta can be written as m2 minus m1 upon 1 plus m1 into m2, and because of this tan pi minus theta, we will take the minus sign also. So a general intersection of two lines will give us two values of theta. Both the values will be supplementary to each other, because we know that whenever two lines intersect, they give us two angles. What will happen if both the lines are parallels? See, what we are talking over here is that if we have line L1 as this and line L2 as this, so they are not intersecting, which means that the angle of intersection is 0, and the supplementary part of that is going to be pi. So we are taking it for 0. If tan theta is 0, so what we can say that from the expression m2 minus m1 upon 1 plus m1 m2, the numerator part is going to be 0, and if the numerator part is 0, we can say that it will lead us to a result that will be nothing but m2 minus m1 being equal to 0, so m2 will be equal to m1. Hence the condition for two lines to be parallel. So this we can say in words as, if the slope of two lines is equal, then the two lines are said to be parallel. So next, move towards the case of perpendicular lines. What do we have to say when the lines are perpendicular? See, when the lines are perpendicular, the angle between them is nothing but pi by 2, right? And so tan of theta was m2 minus m1 upon 1 plus m1 into m2, and tan theta is nothing but sine theta by cos of theta. If this is the case, I can say that m2 minus m1 upon 1 plus m1 into m2, the denominator part is going to be 0. So if the denominator is 0, I can very well say that cot theta is 0. So denominator will become the numerator, and 1 plus m1 plus m2 will be equal to 0, and m1 into m2 will be minus 1. Whenever we have two lines and the product of slope, mind you, this is very important, not the sum, not the difference, it is just the product of slopes. If the product of slopes is equal to minus 1, then we will say that those lines are perpendicular to each other. As we have read the various concepts, so let us try to implement them by doing questions. The first in that series will be, show that the equations to the straight line passing through the point 3 comma minus 2 and inclined at an angle of 60 degree to the line y plus root 3x will be y plus 2 equal to 0 and y minus root 3x plus 2 plus 3 root 3 equal to 0. So first of all, let us try to understand the question graphically, what it is. So suppose this is the line that is being given to us, that is y plus root 3x equal to 0, and there is a point which is fixed, that is 3 comma minus 2, and there are lines which is making an angle of 60 degree with these. So we'll consider there will be two possible cases, because these two lines can make an angle of 60 degree, right? So this is how we'll get two lines, and that is what we have to show in the question also. The slope of this line is known and the slope of these two lines is not known. So this is what we have to find out, and how we will find out that, we will use the equation, that is tan of theta is nothing but mod of m2 minus m1 upon 1 plus m2 into m1. In this equation, I know the value of theta, I know one of the values of slope, so one variable will be remaining and I can find out that very easily. So first of all, we will consider that the slope of the required line is m, and then use the formula that just discussed. Mind you, in that we will take y as minus of root 3x, and the slope value for the known line will be minus of root 3. So this is how we have inserted the value of minus root 3 into the equation, and this is how what we have got. So we'll open this up with two values, plus and the minus, and let us see what we get after that. If we open up with this, so there will be two equations that we'll be getting, m plus root 3, and that will be equal to root 3 minus 3m. This is the line that we get when we open this up with the positive sign, and m plus root 3 equals to minus root 3 plus 3m. This is the equation for m, what we get when we open this up with the negative sign. So we'll get the two values of m, that is 0 and root 3. So we have a fixed point and the fixed slope, so I can define the line by using the method y plus root 2 upon x minus 3. First case it will be equal to 0. Second will be y plus 2 upon x minus 3 equal to root 3. So this can be nothing but written as y plus 2 equal to 0, and this will be written as y plus 2 equals root 3x minus 3 root 3. Transposing everything on the left hand side, so this will be the final format of the equations. First one being the y plus 2 equal to 0, and the second one being y minus root 3x plus 2 plus 3 root 3 equal to 0. So while studying the chapter of straight lines from the sessions, if you have had any doubt, you have to go to the website www.askIITians.com. Over there you will see a discussion board. Click on that. Then on the right hand side of the page you will see ask experts. First of all, go and select your category. You can choose the category, then you will post your question, and after that you will click on to get answer. We experts at Ask IITian will revert back to you in 24 to 48 hours with the solution. So in this part, you have seen that whenever two lines intersect, how can we find a relation with respect to the trigonometric quantities that we have learnt into the previous classes. In the next coming part, we are going to see the different forms of representation of a straight line and their various applications. So stay tuned.